So now I'm going to explain the laboratory activity 2. The line import numpy as np, again just like the lab activity 1, is providing mathematical tools and array handling. The import matplotlib.pyplot is used for plotting and displaying graphs. So these two sa pinaka-top are standard for signal processing and plotting in Python. So the n equals np.arrange negative 10, 11, 1 represents discrete time samples, the x-axis in each plot. So the impulse equals np dot where n equals 0, 1, 0. Uh, this means if n equals 0, it sets the value to 1. Otherwise, it sets to 0. This produces a signal that's 0 everywhere except at n equals 0, where it equals to 1. This is discrete impulse function. So the next is the step equals np, where n is greater than equal 0, 1, 0. So if n, it creates a step function which turns on at n equals 0 and stays 1 after that. The ramp signal equals the ramp equals np that where n is greater than or equal to 0 and 0. It starts increasingly linearly from 0 for n greater than 0. This stimulates a ramp function increasing step by step. So the expo equals np where n is greater than equal 0, 0.8 times n 0. This line naman gives an exponentially decaying signal because 0.8 is less than 1. So as n increases, 0.8 decreases towards 0. So the sinusoid equals np. This line produces a cosine wave sampled at discrete time points. So this line makes it easy through i- to loop through and plot each signal automatically. And this line naman, um, this loop ensures each signal is plotted separately and neatly. So this line is for my name to parang yung watermark ko. So ito yung these are the coordinates. Done. So let's see the output. So the first is the in unit impulse, unit step, ramp, exponential, cosine. Yun.